last class you have seen some types of enthalpy changes, that is enthalpy of combustion, enthalpy of reaction, so on and so forth. Okay, Nodi? Now let us see some other enthalpy changes. Okay. First, in fact, you have studied Hess's law of enthalpy, constant enthalpy summation. Hess's law of constancy of enthalpy summation states whether a chemical reaction occurs in one step or through several steps. Of course, some chemical reactions take place through a number of steps. Okay, whether chemical reaction occurs in one step or through several steps, the net enthalpy change of reaction is always same. Okay, ಅದಕ್ಕೆ ಎಕ್ಸಾಂಪಲ್ ನೋಡಿದರೆ ಇದನ್ನು ಈಗ ನಾವು ಅದರ ಅಡ್ವಾಂಟೇಜ್ ನೋಡೋಣ. Here. Now let us see some other enthalpy changes. I would like to discuss on lattice enthalpy. Lattice enthalpy. Enthalpy of solution. Enthalpy of solution. Okay. First, let us say lattice enthalpy. What is lattice enthalpy? Lattice ಅಂದ್ರೇನು? Crystal geometry, structure. See, in the case of crystalline solids, constituent particles in the crystalline solids or in solids, constituent particles may be atoms, molecules, ions, so on and so forth. The constituent particles are arranged in a close packed form. The close packed arrangement of constituent particles in a three-dimensional space is known as crystal lattice. So, solids ನಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, ಕಾನ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಒಂದು ಡೆಫಿನೆಟ್ ಫಾರ್ಮ್ನಲ್ಲಿ ಅರೇಂಜ್ ಆಗಿರುತ್ತೆ. The constituent particles are arranged in a definite particles, that in a three-dimensional fashion. Okay, that arrangement is known as lattice, crystal lattice. Enthalpy of lattice means it is the enthalpy change which takes place when 1 mole of a crystalline solid, say ionic solid, breaks into its constituent ions in gas phase. It is the enthalpy change which takes place when 1 mole of an ionic compound breaks into its constituent ions in its gaseous state. That is enthalpy of lattice or lattice enthalpy. Lattice enthalpy is generally denoted by the letter or by the term delta H, lattice. Okay. What is lattice enthalpy? It is the enthalpy change which occurs when 1 mole of an ionic compound in its gaseous state dissociates, breaks into its constituent ions in the gaseous state. That is, for example, sodium chloride. Sodium chloride is a crystalline solid made up of sodium ions and chloride ions. Ions are the species carrying either positive charge or negative charge and made up of atom or group of atoms. Atom or group of atoms ಇಂದಾಗಿರುತ್ತೆ. Positive charge or negative charge ಇರುತ್ತೆ. Okay. The sodium chloride is an ionic solid. It is made up of sodium ion, positively charged sodium ion and negatively charged chloride ion. Okay. ಈಗ ಇದು ಬ್ರೇಕ್ ಆಯಿತು ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. ಫ್ರಮ್ ಇಟ್ಸ್ gaseous state it breaks to form sodium ion and chloride ion. Okay. This is the process of breaking of lattice. The enthalpy change taking place here is known as lattice enthalpy, and of course it is 788 kilojoule per mole. 788 kilojoule per mole. It is 788 kilojoule per mole is the lattice enthalpy of sodium chloride. That means 788 kilojoule per mole of energy required to break 1 mole of gaseous sodium chloride into its constituent ions of sodium and chloride. Okay. This is regarding lattice enthalpy. Even if you consider the reverse reaction, in such case delta H will be minus 788. Minus 788. That is also known as lattice enthalpy. In such case, it is defined as it is the enthalpy change which takes place when 1 mole of an ionic compound is formed from its constituent ions in their gaseous state. ಇದು ಒಂದು ಜ್ಞಾಪಕ ಇಟ್ಕೊಂಡಿರಿ. You just remember this. In a reversible reaction, if forward reaction is exothermic, then backward reaction will be endothermic. Okay. In both the cases, the net enthalpy change is same but with opposite sign. ಒಂದು ರಿವರ್ಸಿಬಲ್ ರಿಯಾಕ್ಷನಲ್ಲಿ ಏನಿರುತ್ತೆ, in a reversible reaction, the enthalpy change accompanying in the forward reaction, magnitude of enthalpy change accompanying the forward reaction will be same as that of backward reaction, or when the same reaction occurs in the reverse direction, but with opposite sign. Sign ಏನಾಗಿರುತ್ತೆ, opposite ಆಗಿರುತ್ತೆ. In fact, it is known as Laplace-Lavoisier law ಅಂತ ಹೇಳ್ತೀವಿ ಇದನ್ನು. ಓಕೆ. ಸೊ ಈ ಡೈರೆಕ್ಷನಲ್ಲಿ ರಿಯಾಕ್ಷನ್ ಎಂಥಾಲ್ಪಿ 788 ಕಿಲೋಜೌಲ್ ಪರ್ ಮೋಲ್ ಪ್ಲಸ್ ಅಂತ ಹೇಳಿದ್ರೆ ಅಂದರೆ ಆಯಿತು, ದಿಸ್ ಪ್ರೋಸೆಸ್ ಇಸ್ ಎಂಡೋಥರ್ಮಿಕ್. ಟು ಬ್ರೇಕ್ ಸಾಲಿಡ್ ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್ ಇಂಟು ಅಯಾನ್ಸ್ we have to supply energy to it. It is an endothermic reaction. On the other hand, formation of sodium chloride from sodium ion and chloride ion will be exothermic, where the enthalpy change will be minus 788 kilojoule per mole. This is lattice enthalpy. Next, let us see enthalpy of solution. What is solution? In solution andre the homogeneous mixture of solute and solvent is known as solution. Generally, when solute is put into suitable solvent, the solute dissolves in the solvent to form a homogeneous system known as solution. Solute solvent mix ಆಗಿ homogeneous system ಬಂದರೆ that system is known as solution. Okay. Now, what is enthalpy of solution? What is lattice enthalpy? It is the enthalpy change which takes place when 1 mole of an ionic compound breaks into its constituent ions in gas phase. ರಿಯಾಕ್ಷನ್ ಯಾವ ಫೇಸಲ್ಲಿರಬೇಕು? ಗ್ಯಾಸ್ ಫೇಸ್, ಗೇಷಿಯಸ್ ಸ್ಟೇಟಲ್ಲಿ ಆಗಬೇಕು. ಓಕೆ, ಹಾಗೆ ಇದನ್ನು ಸ್ಟೇಟ್ ಮಾಡಿ ಎಂಥಾಲ್ಪಿ ಆಫ್ ಸೊಲ್ಯೂಷನ್. ಎಂಥಾಲ್ಪಿ ಆಫ್ ಸೊಲ್ಯೂಷನ್ ಮೀನ್ಸ್ it is the enthalpy change which takes place when 1 mole of a solute, ಜ್ಞಾಪಕ ಇಟ್ಕೊಂಡಿರಬೇಕು, ಸುಮ್ಮನೆ ಯಾವ್ಯಾವುದೋ ಅಮೌಂಟ್ ಅಲ್ಲ, 1 mole of solute dissolve completely in sufficient, of course, in sufficient amount of solvent at given conditions. The enthalpy change which takes place when 1 mole of a solute dissolve completely in excess of solvent, such that there will be no change in enthalpy on further dilution. ಫರ್ದರ್ ಡೈಲ್ಯೂಷನ್ ಮಾಡಿದಾಗ ಎಂಥಾಲ್ಪಿ ಚೇಂಜ್ ಇರಬಾರ್ದು. ದಟ್ ಈಸ್ ದ ಕಂಡೀಷನ್. ಸೊ ಎಂಥಾಲ್ಪಿ ಆಫ್ ಸೊಲ್ಯೂಷನ್ ಮೀನ್ಸ್ ಇಟ್ ಈಸ್ ದ ಎಂಥಾಲ್ಪಿ ಚೇಂಜ್ ವಿಚ್ ಅಕರ್ಸ್ ವೆನ್ 1 mole of a substance, that means solute, is completely dissolved in sufficient amount of solvent at the given condition. Okay, ನೋಡಿ this one, sodium chloride. Okay, when sodium chloride dissolve in water, that means it is liquid. This one is in the solid state. You will have sodium chloride solution, or else you can write aqueous sodium chloride. Aqueous sodium chloride. Okay, here the enthalpy change taking place is known as enthalpy of solution, delta H solution. That is, I will give the value of delta H of this solution. Okay, now the interesting thing is when you put particularly an ionic solvent, particularly ionic, not solvent, ionic solute in suitable solvent, it will not simply dissolve in it. ಸುಮ್ಮನೆ ಸಿಂಪಲ್ ಆಗಿ ಡಿಸಾಲ್ವ್ ಆಗೋದಿಲ್ಲ. ಓಕೆ, ಆ್ಯಕ್ಚುಲಿ 2 steps take place during dissolution of an ionic compound in suitable solvent. Which are the processes taking place while dissolving an ionic compound in the given solvent? That is interesting one. Okay, enthalpy of solution can be defined as it is the enthalpy change which occurs, which takes place when 1 mole of solute, keep it in mind, how much amount? 1 mole of solute dissolve in sufficient amount of solvent, dissolve completely in sufficient amount of solvent at the given conditions of temperature, pressure, etc., etc., etc. Okay, when you put sodium chloride in water, okay, when you put sodium chloride in water, first it dissociates. That means sodium chloride breaks into sodium ion and chloride ion. ಏನಾಯ್ತಪ್ಪ ಇಲ್ಲಿ? ಲ್ಯಾಟಿಸ್ breaking takes place. That means enthalpy change taking place here is known as lattice enthalpy. Okay, delta H lattice. Okay, next bit is these ions formed in the solvent get solvated. they are surrounded by solvent molecules. Okay, these ions get solvated by solvent molecule. That means these ions are surrounded by large number of water molecules. Process is known as solvation. It is known as solvation. So ions first ಏನಾಗಿದೆ, ionic crystal break ಆಗಿದೆ into constituent ions. Process is known as ionization. Okay, ionization ಆಯಿತು, lattice break ಆಯಿತು, enthalpy change is known as lattice enthalpy. Okay, this is 788 kilojoule per mole. This lattice enthalpy, that is lattice enthalpy of sodium chloride, is found to be 788 kilojoule per mole. Next, sodium ion and chloride ion get solvated. Okay, that means that takes up solvent molecules, that is aqueous chloride ion and aqueous sodium ions are formed. This process is known as solvation. This is dissociation, it is solvation. The enthalpy change taking place is known as solvation enthalpy. It is known as solvation enthalpy. Okay, here it is found to be minus 784 kilojoule per mole. 784 kilojoule per mole. Okay, just see. Now you bring your Hess's law to get this value, enthalpy of solution. Okay, therefore enthalpy of solution must be equal to lattice enthalpy plus enthalpy of solvation. Lattice enthalpy plus enthalpy of solvation. Okay, according to your Hess's law. Hess's law ಏನು ಹೇಳುತ್ತಪ್ಪ, whether a chemical reaction occurs in one step or through several steps, net enthalpy change of reaction will be same, or the net enthalpy change of reaction is equal to sum of the enthalpy changes taking place in the intermediate steps. That is in the intermediate steps. ಈ ಸ್ಟೆಪ್ಸ್ನಲ್ಲಿ ಎಲ್ಲ ಎಂಥಾಲ್ಪಿ ಚೇಂಜಸ್ ಏನಿದೆ ಅದರ ಸಮ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ಎಂಥಾಲ್ಪಿ ಆಫ್ net reaction. Okay, so enthalpy of solution must be equal to lattice and sum of the lattice enthalpy and enthalpy of solvation. Then come and tell me how much it is. So therefore enthalpy of solution of sodium chloride is, lattice enthalpy is 988 kilojoule per mole. Okay, whereas that of solvation enthalpy is minus 784 kilojoule per mole. You just see here, lattice enthalpy endothermic, taking place through absorption of heat. Solvation enthalpy or solvation is exothermic, heat is liberated. What about the net heat change? It will be 4 kilojoule per mole. 4 kilojoule per mole. ಏನು ಸೈನ್ ಇದೆ? ವಾಟ್ ಇಸ್ ದ ಸೈನ್ ಆಫ್ ಎಂಥಾಲ್ಪಿ ಆಫ್ ಸೊಲ್ಯೂಷನ್ ಆಫ್ ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್? ಪ್ಲಸ್. ದಟ್ ಮೀನ್ಸ್ endothermic. Heat is absorbed. The solvation, the dissolution of sodium chloride in water is followed by absorption of heat. That's why when you dissolve sodium chloride in water, temperature falls, temperature of surrounding falls. ನೀವು ಟೆಸ್ಟ್ ಮಾಡಿ ನೋಡ್ಬೋದು ಅದನ್ನು. ನಾನು ಅದನ್ನು ನಿಮಗೊಂದು ಲಾಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ಹೇಳಿದ್ದೀನಿ. ಕೈನಲ್ಲಿ ಯು ಜಸ್ಟ್ ಟೇಕ್ ಎ ಸ್ಪೂನ್ ಆಫ್ ಕಾಮನ್ ಸಾಲ್ಟ್ your hand, put it in water. ವಾಟರ್ನಲ್ಲಿ ಇಡಿ ನಿಮ್ಮ ಕೈನ, ನಿಮ್ಮ ಕೈ ತಣ್ಣಗಾಗುತ್ತೆ, ವಿಲ್ ಫೀಲ್ ಕೋಲ್ಡ್. ಯಾಕೆ ಕೋಲ್ಡ್ ಆಗುತ್ತೆ? ಬಿಕಾಸ್ ದ ಡಿಸೊಲ್ಯೂಷನ್ ಆಫ್ ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್, ಫಾರ್ಮೇಷನ್ ಆಫ್ ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್ ಸೊಲ್ಯೂಷನ್ is endothermic. Okay, in some cases solution enthalpy plus irutte, I mean minus irutte, exothermic ಆಗಿರುತ್ತೆ, heat is liberated. For example, soap dissolve ಆಗೋಗಿ heat liberate ಆಗುತ್ತೆ. This is regarding lattice enthalpy and enthalpy of solution. Okay, next we shall see another type of enthalpy or enthalpy change, that is enthalpy of atomization. Enthalpy of atomization. What is atomization? You know, when two or more than two atoms of same element or different elements combine, a molecule is formed. Atoms more than, I mean two or more than two atoms combine ಆಯಿತು ಅಂದರೆ ಏನು ಬರುತ್ತಪ್ಪ ನಿಮಗೆ? ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಬರುತ್ತೆ. ಓಕೆ, breaking of molecules into constituent atoms, breaking of molecules into constituent atoms is known as atomization. Process is known as atomization. Very simple. 1 rupee ಕಾಯಿನ್ ಇದೆ, ಅದನ್ನು ಬ್ರೇಕ್ ಮಾಡಿದ್ರೆ, ಡಿಸೋಷಿಯೇಟ್ ಮಾಡಿದ್ರೆ ಕಾನ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ಸ್ ಏನಿರುತ್ತೆ 1 ರೂಪಾಯಿ ಕಾಯಿನಲ್ಲಿ? 1 NP ಕಾಯಿನ್. ಆಫ್ ಕೋರ್ಸ್ ನೌಡೇಸ್ ಇಟ್ ಈಸ್ ರೇರ್ ಟು ಸೀ 1 NP ಕಾಯಿನ್. 1 NP ಇದಿರಲಿ, 10 NPನೂ ಸಿಗಲ್ಲ, 25 NPನೂ ಸಿಗಲ್ಲ, 50 NP ಸಿಗೋದು ಕಷ್ಟ ಇದೆ, ಗೊತ್ತಾಯ್ತಾ? ಯಾಕೆಂದರೆ ದೇ ಆರ್ ನಾಟ್ ರನ್ನಿಂಗ್. ಓಕೆ, ಬೆಟರ್ 10 ರೂಪಿ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ, ಆರ್ 2 rupees ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. 2 ರೂಪಿ ಇಸ್ ಮೇಡ್ ಅಪ್ ಆಫ್ 2 1 rupees. 2 ರೂಪಾಯಿ ಯಾವುದರಿಂದ ಆಗಿರುತ್ತೆ? 2 1 ರೂಪಾಯಿಯಿಂದ ಆಗಿರುತ್ತೆ. ದಟ್ ಈಸ್ ಬ್ರೇಕಿಂಗ್ ಆಫ್ 2 rupee note into 1 rupee note or coins is known as atomization. So conversion of molecules into atoms, constituent atoms, is known as atomization. During that process also, enthalpy change takes place. The enthalpy change which takes place when 1 mole of a molecule, 1 mole of a molecule or 1 mole bond of a molecule breaks into constituent atoms in gas phase. That is enthalpy of atomization. The enthalpy change which occurs when 1 mole of covalent, 1 mole of bonds are broken from 1 mole of molecule into constituent atoms in their gaseous states at the given condition is known as enthalpy of atomization. 1 mole compound ತಗೊಳ್ಳಿ, ಅದರಲ್ಲಿ 1 mole ಬಾಂಡ್ ಬ್ರೇಕ್ ಮಾಡಿ, ಓಕೆ, 1 mole ಬಾಂಡ್ ಬ್ರೇಕ್ ಮಾಡಿದಾಗ ಟು ಫಾರ್ಮ್ ಕಾನ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ಆಟಮ್ಸ್. ಓಕೆ, ಬ್ರೇಕ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್, 1 mole of bonds in molecule, 1 mole molecule into constituent ions to form constituent ions in gaseous state or gas phase. Enthalpy change occurring is known as enthalpy of atomization. Okay, you just say this one: H2 molecule, that is dihydrogen molecule. H2 is known as dihydrogen molecule, or simply we used to call it as hydrogen molecule. It is made up of 2 hydrogen atoms. Okay. Consider 1 mole of hydrogen molecule, diatomic hydrogen molecule. 1 mole of hydrogen molecule contains 1 mole of bond. ಎಷ್ಟಿರುತ್ತೆ 1 mole bond ಇರುತ್ತೆ. ಇದನ್ನು ಬ್ರೇಕ್, 1 mole, that is 1 time Avogadro number, that means 6.023 into 10 to the power of 23 bonds. Okay. 1 mole of hydrogen molecule, when breaks to form its constituent atoms. Which are the constituent atoms? Hydrogen atoms, that is 2H. In the gaseous state, the enthalpy change taking place is known as enthalpy of atomization. Yathik enthalpy of atomization antira, molecule is converted into atoms. In this case, molecules are converted into atoms, and enthalpy change taking place is known as enthalpy of atomization. Okay. In this case, it is 435 kilojoule per mole. The enthalpy of atomization of dihydrogen or hydrogen molecule is found to be 435 kilojoule per mole. What is the nature of the process? It is endothermic. That means it is followed by absorption of energy, heat. Yakidu absorption agbeku energy instead of liberation? Why this process is exothermic, not endothermic? Sorry, endothermic but not exothermic? Simple thing. See here, in dihydrogen or hydrogen molecule, there is a bond between 2 hydrogen atoms. 2 hydrogen atoms madhye enirutte bond irutte. To break the bond, we have to supply energy. To break the bond, we have to supply energy. That's why atomization process is endothermic in nature. Normally endothermic in nature. Okay. So this 435 kilojoule per mole is known as enthalpy of atomization of dihydrogen or diatomic hydrogen. Not dihydrogen, diatomic hydrogen or hydrogen molecule. That means to convert 1 mole of H2 molecules into H atoms, the amount of energy required is 435 kilojoule per mole. To convert 1 mole of diatomic hydrogen or hydrogen molecule into hydrogen atoms, enthalpy or amount of energy required is 435 kilojoule per mole, and it is known as enthalpy of atomization of hydrogen, diatomic hydrogen. Similarly, for oxygen, O2 into O, N2 into N, Cl2 into Cl, like that. Okay, idu enthalpy of atomization. Next, we shall see another form of enthalpy change or type of enthalpy change, that is bond enthalpy. Bond enthalpy. Bond enthalpy is of 2 types. ಇದು 2 ರೀತಿ ಇರುತ್ತೆ. ಯು ಕ್ಯಾನ್ ಸಿಂಪ್ಲಿ ಇಮ್ಯಾಜಿನ್ ಏನು ಬಾಂಡ್ ಎಂಥಾಲ್ಪಿ ಅಂದರೆ ಏನದು ಗೊತ್ತಾಗಿರುತ್ತೆ. ಈಗಲೇ ಸುಮಾರು ಡೆಫಿನೇಷನ್ ಗೊತ್ತು. ಸೊ ಫಾರ್ ಹ್ಯಾವ್ ಸ್ಟಡಿಡ್ ನಂಬರ್ ಆಫ್ ಟೈಪ್ಸ್ ಆಫ್ ಎಂಥಾಲ್ಪಿ ಚೇಂಜಸ್ ಆ್ಯಂಡ್ ದರ್ ಡೆಫಿನೇಷನ್ಸ್. ಈಗ ನೀವೇ ಹೇಳ್ಬೋದು ಬಾಂಡ್ ಎಂಥಾಲ್ಪಿ ಮೀನ್ಸ್ it is the enthalpy change which takes place during breaking of bond or making of bond. Okay, during chemical reaction, what is chemical reaction? A chemical reaction is nothing but breaking of bond and making of bond. ಯಾವುದೋ ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಇಂಟ್ರ್ಯಾಕ್ಟ್ ಆಗ್ತಿರುತ್ತೆ, ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಇಂಟ್ರ್ಯಾಕ್ಟ್ ಆಗುವಾಗ ಸಮ್ ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಬಾಂಡ್ಸ್ ಆರ್ ಬ್ರೋಕನ್, ನ್ಯೂ ಕಾಂಪೌಂಡ್ಸ್ ಆರ್ ಫಾರ್ಮ್. ಡ್ಯೂರಿಂಗ್ ದ ಫಾರ್ಮೇಷನ್ ಆಫ್ ನ್ಯೂ ಕಾಂಪೌಂಡ್ಸ್ ಆರ್ ಕಾಂಪೌಂಡ್, ನ್ಯೂ ಬಾಂಡ್ಸ್ ಆರ್ ಫಾರ್ಮ್. So breaking and making of bonds is nothing but chemical process or interaction. Okay. See, bond enthalpy, it is of two types. One is bond dissociation enthalpy. Bond dissociation enthalpy. Another one is mean or average bond dissociation enthalpy. Mean or average bond dissociation enthalpy. It is often known as dissociation enthalpy. Bond enthalpy is also known as dissociation enthalpy. Okay. What is bond enthalpy? Bond dissociation enthalpy. It is the enthalpy change takes place when all the bonds of 1 mole of covalent molecule is broken to form the products in gaseous state. 1 mole covalent molecule ತಗೊಳ್ಳಿ, ಅದರೊಳಗಿರೋ covalent bondsನೆಲ್ಲ ಬ್ರೇಕ್ ಮಾಡಿ. 1 mole covalent bonds ಬ್ರೇಕ್ ಮಾಡಿ. ಆ ಮಾಲಿಕ್ಯೂಲ್ ಯಾವ ಸ್ಟೇಟಲ್ಲಿ ಇರಬೇಕು? gaseous state. Okay, to form products in the gaseous state. That means you have to carry out the reaction or process in gaseous state or gas phase. Okay, so enthalpy change which occurs when 1 mole of covalent bonds are broken from 1 mole of a compound, molecule or compound, in its gaseous state into gaseous atoms, constituent gaseous atoms. It is something like your first one, bond enthalpy. It is nothing but your bond enthalpy. Here, you are breaking 1 mole of covalent bond. Of course, in hydrogen molecule, the bond between hydrogen atoms is nothing but covalent bond. From 1 mole of hydrogen molecule, you have to break 1 mole of covalent bond to form the constituent atoms. Or, of course, no doubt it is products. Okay, here the enthalpy change taking place can be taken as bond dissociation enthalpy. Bond dissociation enthalpy. Now that 435 kilojoule per mole can be considered as bond dissociation enthalpy of hydrogen molecule. So this bond dissociation enthalpy normally holds good to diatomic molecules, or one can say homo molecules. Homo means same type of atoms combined again. H2, Cl2, Br2, N2 ಇವೆಲ್ಲ corresponding atoms are convert ಆಗೋದ್ರಲ್ಲಿ dissociation enthalpy can be taken as bond dissociation enthalpy. Okay, another one is mean bond dissociation enthalpy. This mean bond dissociation enthalpy holds good in the case of polyatomic molecules. That means molecules made up of more than 2 atoms. More than 2 atoms. Of course, of different elements are same. ಪಾಲಿಅಟಾಮಿಕ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ನಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, ಬಾಂಡ್ ಡಿಸೋಸಿಯೇಷನ್ ಎಂಥಾಲ್ಪಿ ಆರ್ ಡಿಸೋಸಿಯೇಷನ್ ಎಂಥಾಲ್ಪಿ ಆಫ್ ಮಾಲಿಕ್ಯೂಲ್ into constituent atoms is expressed in terms of mean or average dissociation enthalpy. Okay, mean or average dissociation enthalpy. Okay, let us see one example for this. Methane. Okay. Before that, I would like to give one important relationship. That means enthalpy of reaction. Enthalpy of reaction is equal to bond enthalpy, bond dissociation enthalpy of reactants, bond dissociation enthalpy of reactants minus bond enthalpy of products. This equation or relationship is important. Okay, the enthalpy of reaction is the difference in bond enthalpies of reactants and products. Bond enthalpy of reactant minus bond enthalpy of product. That is. Next problem ಮಾಡಿಸುವಾಗ ಗೊತ್ತಾಗುತ್ತೆ ನಿಮಗೆ ಹೇಗೆ ಅನ್ನೋದನ್ನು. Okay, there I will give an example for that. Now, consider a polyatomic molecule, methane. Methane is formed by the combination of 1 carbon and 4 hydrogens. 1 atom of carbon and 4 atoms of hydrogen. Okay. This on dissociation, complete dissociation, that is on subjecting the thermal dissociation, you will get carbon and hydrogen. C plus 4H. On complete breaking off, that is all the bonds in methane. In methane there are 4 bonds, 4 CH bonds. See, methane can be represented like this. CH, H, H, H. Okay, there are 4 CH bonds in methane. Okay, when you break all these 4 bonds, when you dissociate all the 4 bonds of methane, that is 4 CH bonds of methane, methane is simply converted into carbon and 4 hydrogen. Okay, the enthalpy change taking place here, it is known as net enthalpy change. Net enthalpy change or dissociation enthalpy of methane. The dissociation means complete breaking of all the bonds in the given compound to form constituent atoms or atoms of constituent elements. Okay, so here it is found to be 1625 kilojoule per mole. What is 1625 kilojoule per mole? It is the dissociation enthalpy. Dissociation enthalpy of methane. That means the enthalpy change which occurs when all the 4 bonds, 4 CH bonds of methane, 1 mole of methane, are completely broken. 1 mole methane alliru ella CH bonds nu complete break ಮಾಡಿದಾಗ ಎಷ್ಟು ಎಂಥಾಲ್ಪಿ ಚೇಂಜ್ ಇದೆ, that is known as dissociation enthalpy of methane. It is found to be 1665 kilojoule per mole, and simply known as dissociation enthalpy. Okay. How this dissociation occurs? No. Okay. Let us say first, in methane, one of the CH bond breaks. One of the CH bond breaks to form CH. Of course, all these reactions take place in the gaseous state. Okay, CH3 plus H. Here, one bond breaks. The enthalpy change taking place is known as bond dissociation enthalpy. Bond dissociation enthalpy, that is first bond dissociation enthalpy. That is delta H1 bond, let us call it. Okay, next I will give the values of those delta H. Next, in the next step, another bond dissociation takes place. First, one bond breaks to form CH3. From CH3, another CH bond breaks to form CH2 and H. Here the enthalpy change taking place is known as second CH bond dissociation enthalpy. Okay. Next, another CH bond breaks to form CH plus H. It is known as third bond dissociation enthalpy of methane. Finally, last CH bond breaks. Okay, that is C plus H, which is known as fourth bond dissociation enthalpy or bond enthalpy of methane. Okay. The first bond dissociation enthalpy is found to be 427 kilojoule per mole. Okay. Second bond dissociation enthalpy is found to be 439 kilojoule per mole. Next one, 452 kilojoule per mole. And last one, 347 kilojoule per mole. It is altogether, it is not 1665, 25, it is 1665. Okay. See, this dissociation enthalpy is the sum of all this bond dissociation enthalpy. The dissociation enthalpy of a molecule is nothing but sum of the bond dissociation enthalpies of individual bonds. Okay. See here, when you add all these things, all these values, that is delta H1 plus delta H2 plus delta H3 plus delta H4, bond dissociation of course, which will be 1665 kilojoule per mole. It is dissociation enthalpy. Now I want mean bond enthalpy, mean dissociation enthalpy. What is this mean dissociation enthalpy? That is delta H, mean bond dissociation or average bond dissociation enthalpy. This is equal to sum of delta H of bond dissociation divided by number of bonds broken or dissociated. Okay. That is, you can write this one as delta H dissociation. Dissociation enthalpy. What is dissociation enthalpy? It is the enthalpy change which takes place when 1 mole of a compound, that is bonds present in 1 mole of compound, all the bonds in 1 mole of compound is completely broken to form constituent atoms. Okay, so delta H dissociation by number of bonds broken. Okay, that means delta H, mean of your methane, the mean dissociation enthalpy or mean bond dissociation enthalpy or average bond dissociation enthalpy of methane is equal to, what is the dissociation enthalpy? Dissociation enthalpy, it is the enthalpy change which takes place when all the bonds are broken, that is 1665 divided by number of bonds broken. How much it is? 4. Okay, it is okay 416.25 I think kilojoule per mole. So what is the average bond dissociation enthalpy of methane? 416.25 kilojoule per mole. Now ಏನು ಬೇಕು to break each bond in CH4 or methane, an average of 416.25 kilojoule energy required. This is regarding mean bond dissociation enthalpy, bond dissociation enthalpy, atomization enthalpy, etc. Okay? Yes.